All right, we're into the last bit of section 3.2, which is Chebyshev's inequality. Now, Chebyshev was a guy that thought of this. That's why I said his last name. And we're not going to do it with it too much. It's just that if a data set is not normal, right? So we use, let me just make a note. We use Chebyshev when a data set is not normal or is unknown. See, the thing about the empirical rule is great, but it only works if you know the data is normal. If you don't know what it is, or you know it's not normal, if you know it's skewed or something like that, then you're kind of stuck. So what we can do is we can say, okay, if you have 2 standard deviations, then we know that at least, and then there's this formula, 1 minus 1 over k squared, let's see, times 100%. Okay, which would be like, for example, 1 minus 1 over 2 squared times 100%, which would be equal to 1 minus 1/4 times 100%, which is, of course, 1 minus 1/4 is 3/4, right? 75%. So 3/4 times 100%, which would be equal to 75%. And it will always be that way. You never have to do that calculation again. Oopsie. It's always 75% for 2 standard deviations. 2 standard devs. Right here. And I'm just going to let you know for 3 standard deviations, it would be 1 minus 1/9, which is 88.9%. Okay? So here, I'll do the same thing if you don't believe me. It's 1 over 1 minus, oops, you probably can't see all that. Okay, so it'd be 3 squared, which would be 9, which makes 8/9, which is 88.9%, roughly. You don't have to memorize it, right? These are just always going to be this way, no matter what. So 2 standard deviations is always at least 75%. And then 3 standard deviations is at least 88.9%. If it's normal, you know it's even higher. If it's normal, you know it's 95 and 99.7 respectively. But if you don't know it's normal, then these are the numbers you get. They're lower, right? Because it's not normal. It's skewed, you know. So if you were looking at a picture like graph 1, for example, you know that it's at least 75% within 2 standard deviations. If you're looking at graph like 2, it's at least 95% within 2 standard deviations. See? 75 for this one, 95 for this one. That's because graph 2 is normal, but graph 1 isn't. That's the difference between empirical and Chebyshev. Empirical is if you know it's normal, you get the 95 for 2 standard deviations. Chebyshev is like if you don't know it's normal, you only get 75 for 2 standard deviations. All right? So suppose a new electric generator produces voltage amounts with a mean of 125 volts and a standard deviation of 0.3 volts. Using Chebyshev's theorem, what do we know about the percentage of volts that are within 3 standard deviations? We know that 88.9% of voltage through the generator will be between, and I better go find this, equals 125 plus 3 times, what was my 0.3, and equals 125 minus 3 times 0.3. Okay, between 124 and 125.9. 124.1 volts and 125.9 volts. I want to keep adding an S to that. Stop it. There we go. 88.9 because of this calculation right up here. When they say 3 standard deviations, it'll always be 88.9. If they said 2, it would have been 75, and we would have had to find 2 standard deviations away. This one I found 3. Alrighty, that's Chebyshev, and we are done with section 3.2. See you back here for section 3.3.